Good morning, students. Welcome back to the Maths 1 lecture. As you know that we have started with the practical session, and I hope that whatever we have done with the last 2 days, you must have completed your book. And today is the day 3, that is the third session of this practical one. So students, all of you know that we are starting from the chapter number 1, because in the practical booklet, it is not like first term and second term. Might be due to the late session started in your school, you might have not completed your practical book right from the practical 1. Okay, so in this second term, we have started right from the practical 1. Okay, so today is the day 3rd of Maths 1. So without wasting our time, we will move to the practical booklet. One thing I want to tell you, students, if you have missed out any part, of this practical session of the day 1 and day 2, then you can go to the YouTube channel and watch the videos over there and complete your notes. Okay, if you have already subscribed it. Okay, if you have not subscribed, so subscribe so that you can get the notification of the latest video. Okay, so without wasting much time, we will move to the content, because we have to complete as much as we can. So yesterday we have completed till page number 8. Okay, yesterday we have completed till page number 8. Today we will move to the page number 9. On page number 9, again, one activity question is there. That is a question number 5, if you can see. And I told you that you have to sit along with your practical booklet. Okay, so that if the booklet is in front of you, whatever I am telling, it will be easier for you to correlate with the screen and with your practical book. Okay, so still, if you are not with your practical book, you can take out and open the page number 9. On page number 9, let us see the 5th question, that is a simplify. This is an activity based question, students. Question is what? 2 root 162 plus 7 root 32 minus root 1250. Okay, this is a question, and they have told to fill in the boxes with the proper numbers. Okay, so as I told you that activity question, the whole solutions will be provided to you. In the steps, some missing numbers or some missing steps will be there, and it will be indicated by a block or a simple dash. So that particular boxes or the blanks you need to fill. So this is one type, one of the example of it. So here it is a simplification, and this particular question, it is from the subtopic surds, that is in chapter number 2, real numbers. Okay, and in surds we have seen different type of surds, how to rationalize it, how to add, subtract, multiply and divide. Okay, so here it is a combination of the addition and subtraction of the surds. Okay, so let us see how we can go to it, and we'll fill the boxes and complete the activity question. So here 2 root 62. plus 7 root 35 minus root 1250. Now whatever the surd is there, that is 162, 32, 1250, you can see in the next step. You can see in the next step, here they have given that is 2 root, some block is there, then again multiplied by 2, multiplied by 2, okay? That means you need to simplify, in such a way that it should be a perfect square. It should be a perfect square. So here already given that is root, one simplification I will tell you, 162, okay? 162, you need to simplify in such a way that which number it should be multiplied by 2, and whatever the number here you will write, it should be a perfect square, okay? It should be a perfect square. So if you are not confirmed, or if you are confused, if you are not confirmed and if you are confused, what you can do, you can find out the factors of 162, okay? You can find out the factors of 162, and then you can get the answer, okay? So here 2 as it is outside the bracket, and 162 it can be factorized as 81 into 2, okay? And see students, 81 it is a perfect square root of 9, okay? Then 32 again it is factorized, 7 as it is outside the bracket, it can be written as 16 into 2. 16 is a square root of 4, okay? Then 1250 it is factorized as 625 into 2. Here already the 2 is given. Already the 2 is given. You need to factorize in such a way, whatever the answer you get, it should be a perfect square. It should be a perfect square. So here 81, then 16, 625, okay, multiplied by 2. This multiplied by 2, it is already given to you, and this particular you will get when you factorize the numbers, okay? And all these three numbers, they are the perfect square root, okay? 81, it is a perfect square root of 9, then 16, 4, and 625, it is of 25, okay? So 81 into 2 plus 7 square root 16 into 2 minus square root 625 into 2. So 81 can be written as 9 root 2 plus 7 into 4 root 2 minus 25 root 2. Now here you can see they are what? Similar surds. They are what? Similar surds. So unless and until the surds are not similar, you cannot carry out the addition and the subtraction. Okay, you cannot carry out the addition and subtraction. Before it was 162, then 32. You cannot do addition or subtraction unless and until you make this surd as a similar surd. Okay, similar means what? Same. So here root 2, root 2, root 2. So all the three surds, they are similar. Now you can carry out the addition and the subtraction. So 2 into 9 is 18. Okay, 7 into 4, 28. Then 25 as it is. Okay, so 18 root 2 is common, so that it is outside the bracket. Okay, so it will be what? 18 plus 28 minus 25. Okay, now here you will apply the method of Bodmas. Okay, yesterday only I told you, when there is a combination of the addition, subtraction, that is the mathematical operations, you need to follow the Bodmas rule. Okay, so when you 18 plus 28 minus 25, you will get it as 21. Okay, and root 2 as it is. Okay, root 2 as it is. So the final answer there, you can see that it is what? 21 root 2. So students, from this example, one thing is clear, that any question of the surds come, you need to check whether the surds are similar or not. Okay, you need to check whether the surds are similar or not, and simplify to its lowest form. Okay, simplify to its lowest form, so that you can carry out further mathematical operations. Okay, so this was the activity that was in question number 5. Okay, now as activity questions are completed, below that there are some questions and you need to solve in the space which is provided over there. Okay, so here you can see solve the following examples in the provided space. Okay, now many a time students say it's a division, simple division. Okay, and we are doing the division right from the primary section, but some students really it's means they have difficulty even in a simple division, in a, even in a simple multiplication. That means some students, they don't know the basic mathematical operation. So here if you'll see the question, that is the first one, express the rational number 15 upon 7 in decimal form. Okay, 15 upon 7 in a decimal form. Now this is 15 upon 7, it is a rational number. Okay, you know the definition of the rational number. Rational number, they are of the form P upon Q. Okay, where P and Q, they belongs to real number and Q is not equal to 0. This is the definition of the rational number. So rational number means what? It is a fraction. It is a fraction, and see that in that fraction, when I say word fraction, there should be a numerator, there should be a denominator. Okay, two numbers should be there. So rational number means what? A fraction, that is numerator and denominator. So here 15 upon 7 is a rational number, and this 15 upon 7 you need to convert in the decimal form. That means you have to carry out simple division method, okay, and get the answer, get the quotient in the decimal form. Okay, so here you can see 7, it's quite lengthy, so I have occupied the space of the question number 2. Okay, so here you can see 7, okay, 15 divided by 7, a normal division, but here if you will see 15 minus 14 is 1. Okay, 15 minus 14 is what? 1, and they have told that you should get the answer in the decimal form. So decimal form means what? Either you will continue the division until and unless you will get the 0, okay, or until and unless the digits or the numbers are recurring, means once they start recurring, you need to stop the division. Okay, so these two conditions you have to remember when you are expressing the rational number in the decimal form. Either you will continue till you get the remainder 0, or again I am repeating, the quotient, if it starts recurring, if it starts repeating, then you can stop the division there itself. Okay, so these two conditions you must remember whenever you carry out the division of the rational number. Okay, so here 15 divided by 7, if you see 15 minus 14 is 1. Okay, so 1 we need to carry out unless and until we get the 0 or the recurring numbers. Okay, so decimal as usual. So 7 ones are, then 3, 28, you can see here on the screen. Okay, now after this 7, okay, in the quotient you can see 1. I have written 1. Okay, that is the 7 ones are 7. Again 30. 30 means what? It will be 4s are 28. Okay, then 2. Again I will take 0. Then 2s are, that is 14. Okay, so that means right from the digit 1. Okay, 1, 4, 2, 8, 5, 7. Okay, all these 6 digits, they are recurring. They are what? Recurring. Okay, so as I told you, if the digit starts recurring, you need to stop there itself. Okay, that means your division is completed. Yes, so here till 30 I have stopped here, because after 30 again I will get 4. Okay, again I will get 2, then 8, then 5, then 7. Again it will be 1, 4, 2. That means these digits are repeating, these digits are recurring. So here itself I will stop the division. Okay, after you stop the division, the numbers or the digits which are recurring, okay, the numbers or the digits which are recurring, you need to put a bar on that. You can see on the screen, I have put a bar, okay. That means those digits, they are recurring. Okay, it is understood. When I say that my answer is 2.14, that means none of the digits is recurring and the remainder is 0. Okay, when I say my quotient or the answer is 2.14, okay, 2.14, that means my remainder is 0 and none of the digits is recurring. Okay, but when I say that 2.142 and on 2 if I'll put a bar, that means this digit 2, it is repeating, it is recurring. That means remainder is not getting 0. Okay, so this is very important, or you need to be very careful when you carry out the division of the rational number. Okay, so that was the first example. Now the second one, that is a represent root 7 on a number line. Yesterday I have explained you about the root 2, root 3. Okay, similarly, so if there is time, we can I can show you the how to actually construct. That is a simple construction, not a big construction, a simple construction to represent this on a number line. Okay, now we'll move to the third question, that is show that 4 plus root 5 is an irrational number. Now students, yesterday we have seen that 2 plus root 3 on the number line, this is an irrational number, and we have seen how to represent this on a number line. So here 4 plus root 5, it is also an irrational number. It is also an irrational number. But here what is the question? That you need to show that, you need to prove that this is an irrational number. Okay. So how we are going to prove this? How we are going to prove this? If I'll say that if you are uh, it is not a number, okay, whatever it is, if you want to prove anything, you start with the contradiction part, you start with the contradiction part. Now here I want to prove that this particular number, it is an irrational number. So I will take the contradict means what? Opposite, that it is a rational number. Okay, I will start that it is a rational number, and from that statement I will come to a conclusion that whatever I have assumed, whatever I have taken, okay, that such an so and so number is a rational number, so that is wrong, or it contradicts the statement. Okay, and hence the given number is a rational number. Okay, so let us start. So first statement, it is suppose 4 plus root 5 is a rational number. That means we will assume, okay, we will assume that it is a rational number. So if it is a rational number, students, just now I told you the definition of the rational number. They are of the form what? P upon Q. Okay, they are of the form P upon Q, where P and Q, they belongs to real number and Q is not equal to 0. This definition you need to remember or keep in mind forever. Okay, because this is a shortest definition of the rational number. Okay, so suppose 4 plus root 5 is a rational number, then 4 plus root 5 will be equal to P. Okay, where Q is not equal to 0. Yes, this is the definition as per the rational number. So therefore, root 5 is equal to P upon Q. Now this plus 4 will go this side, it will become minus 4. Okay, plus 4, when it will go this side, it will become minus 4. So here on the left hand side, you can see the root 5. Root 5 is what? It is an irrational number. We have seen, okay. root 5, it is not a perfect square, so it is an irrational number. But whereas on the right hand side, this is a rational number. Why? Because it is of the form P upon Q. Okay, it is of the form P upon Q. Okay, so 4 plus root 5 is an rational number. That means if left hand side, if right hand side is a rational number, then your left hand side will also be a rational number. And we have taken that this is 4 plus root 5, it is a rational number, which contradicts the statement. That means whatever we have assumed, it is false. Okay, whatever we have assumed, assumption we have taken, it is a false assumption. So if it is a false assumption, that means 4 plus root 5, it is a irrational number. Okay, it is an irrational number. So students, here you can see that hardly this proof or the solution, it is of hardly 4 to 5 lines. Okay, and here they have given the example of 4 root 5. They may give the example as 2 plus root 3, okay, 1 plus root 5, any example, and you need to show that this particular is an irrational number. So here the method or the statement will remains the same, only the numbers you need to change. Okay, only the numbers you need to change. So whatever the steps are there, it will be common for all the irrational numbers. Okay, it will be common for all the irrational numbers. But whenever you are writing the steps, see that you write the numbers properly. Okay, so this is how you can prove any irrational number. Okay, now on page number 10. On page number 10, that is question number 4, that rationalize the denominator. Okay, rationalize the denominator. Rationalize means what? You have to make the denominator, means whatever the denominator is there, using that. Okay, in primary section you must have done the cross multiplication and make the denominator same. So this is also a type of that. Okay, so rationalize the denominator. Question is what? 5 plus 3 root 2 upon 5 minus 3 root 2. Okay, so rationalize the denominator. It can be a binomial, it can be a monomial. Okay, it can be a binomial or it can be a monomial. So students, what is the very important steps? That whatever there in the denominator, okay, whatever there in the denominator, you have to take the conjugates. You have to take the conjugates of that particular denominator. Now, what is the meaning of the conjugates? Conjugate means opposite. Okay, conjugates means what? Opposite. That means if in the denominator it is addition or plus sign, you can take the conjugate as subtraction or the minus. If it is minus, then you have to take the plus. Okay, opposite, conjugate. Here you will use the word conjugate, not the opposite. Okay, so first step is what? Conjugate of 5 minus 3 root 2. You can see that 5 minus 3 root 2, it is there in the denominator, and whatever the term is there in the denominator, that terms conjugate you need to multiply in the numerator and in the denominator. Okay, so conjugate of 5 minus 3 root 2 is what? 5 plus 3 root 2. Okay, conjugates of 5 minus 3 root 2 is what? 5 plus 3 root 2. So when you multiply, here you can see 5 plus 3 root 2 upon 5 minus root 3 as it is given in the question, multiplied by this conjugates, that is 5 plus 3 root 2 upon 5 plus 3 root 2. Okay, Now, this is 5 plus 3 root 2 multiplied by 5 plus 3 root 2 will give you what? 5 plus 3 root 2 the whole square. Okay, will give you what? 5 plus 3 root 2 the whole square upon, now here 5 minus 3 root 2 multiplied by 5 plus 3 root 2. Okay, it is of the form that is a minus b, okay, into a plus b. A minus b into a plus b. So the formula is what? A square minus b square. This also you have done in your previous classes. Okay, previous standard. So here it will be 5 the whole square minus 3 root 2 the whole square. That is a is your 5 and b is your 3 root 2. So a square means what? 5 the whole square minus b is your 3 root 2. So it is 3 root 2 the whole square. Okay. Now, in the numerator, it is a whole square. That means it is of the form a plus b the whole square. So what is the formula? That is a square plus 2ab plus b square. This is the formula. Okay. What is the a? It is 5 plus 2 into a into b, that is 2 into 5 into 3 root 2, plus b is what? 3 root 2, that is the 3 root 2 the whole square. I hope the numerator part is clear. It is a simple this formula that is of a plus b the whole square. Okay, that is a square plus 2ab plus b square. And in the denominator, it is what? 5 the whole square, that is 25 minus 3 root 2. Now here 3 root 2. I will tell you the simplification. That means 3, the square of 3 is what? 9 multiplied by root 2 square. Yesterday again I will tell you that yesterday I told you the any number which is there in the root, when it is multiplied, when we take the square, it becomes a whole number. Okay, so root 2 into root 2, it will be what? 2. That is the square of root 2, it will be 2. So 9 2 is what? 18. So here you can see 25 minus 18. Okay, here 5 square is 25 plus 2 into 5, 10, 10 3 is a 30, 30 root 2 plus 18. And in the denominator 25 minus 18. Okay, so here after simplification you will get what? 43 plus 30 root 2 upon 7. Now have you got this 42? Now see students, it is 25 plus 30 root 2 plus 18. Okay, now this particular, it is a surd. We cannot add this 30 with the 25 or with 18. Okay, this need to be kept separately since it is a surd, and this 25 and 18, they are a whole number. So we can add 25 plus 18. Okay, 25 plus 18, that is what? 43, and plus 30 root 2 as it is upon 25 minus 18 is what? 7. I hope the simplification part is clear. Okay. So that was the fourth, that is a rationalize the denominator. So whenever the question comes of the rationalization, you think of the conjugates of the denominator. Okay, you think of the conjugates of denominator, only the denominator. Many a time student takes the conjugate of the numerator, so the answer becomes wrong. Okay, next one, that is the question number 5. Again, it is a simplification part. Okay, so under root 8 upon 9 minus 3 under root 1 upon 2 plus 5 under root 9 upon 8. Okay, so you need to simplify this question. So simplification, how you will go for it? Now 8, it can be written as 4 into 2, okay, upon 3, okay, because What is the cube root of 9? It is 3. Then minus 3. I'm talking about the second step, okay? Minus 3 into 1 upon square root of 1 is what? 1, and square root of 2 is what? Root 2. Okay, so 1 upon root 2 plus 5. 9 can be written as 3 into 3, and 8 can be written as 4 into 2. Okay, so like in the previous example, factorize in such a way that you get a perfect square. So here 2 root 2, that is root 4, it is a perfect square of 2. So it will be, if I'll simplify, see here, 4 into 2. So root 4 into root 2. If I'll separate this, root 4, it is of 2, and here this is root 2 as it is. Okay, so this step. Minus 3 into 1 as it is 3 upon root 2 plus 5. Okay, plus 5 into 3 upon 2 root 2. This third step. Okay. Next, 2 root 2 upon 3 minus here root 2. Just now we have seen the rationalization factor. The same is carried out over here. Plus 5 3s are 15. Okay, root 2 upon 2 root 2 into root 2. So in the next step, 2 root 2 upon 3 as it is, minus 3 root 2 upon 2, because root 2 into root 2 will give you 2, plus 15 root 2, and here 2 root 2 multiplied by 2. 2 root 2 multiplied by root 2. So this root 2 will become 2, and this 2 into 2 will become what? 4. Okay. So in the next step, you can see the denominators 3, 2, 4. Okay. So rationalize the denominator or make the denominator same. So what you will do? You will take the LCM. Okay. You will take the LCM or rationalize the denominator. After rationalizing the denominator, it is what? 3 4s are 12 into 1 is what? 12. 12 ones are 12. So after rationalizing, you will get as 8 root 2 minus 18 root 2 plus 45 root 2. Now here you can see all the surds are similar. Okay, all the surds are similar, and then you can carry out the Bodmas rule. Okay, so that is 88 minus 18 plus 45 root 2 outside the bracket upon 2. You will get what? 35 root 2 upon 12. Okay, and that is the answer which is given here, 35 root 2 upon 12. So normally whenever you get the question of the surds, see that if it is simpler, directly you can carry out, otherwise simplify it, then make it a similar surds. Okay, make here what we have done first, we have simplified the surd. Okay, simplified, then we made the surds equal, that is in here you can see root 2 root 2 root 2. Okay, and then we have carried out our normal mathematical operations. Okay, so the final answer is given here, 35 root 2 upon 12. You can take the screenshot if you have not written. Okay, so that was on page number 10. On page number 11, okay, there is a next practical, that is the practical number 4. Okay, now this particular practical, it is based on chapter number 3, that is polynomials. Okay, the third chapter, polynomial. So here what is the aim? I will just read out. To divide a given polynomial by a linear polynomial by synthetic division method and compare the remainder with the remainder obtained by remainder theorem. Okay, so here whenever you see polynomial, so first you need to identify whether which type of that polynomial. Okay, which type of that polynomial. It is based on the terms and as well as it is based on the degree, that is a linear, quadratic or the cubic polynomial based on the degree. If the degree is 1, it is a linear. If degree is 2, it is quadratic. If the degree is 3, then it is a cubic. Whereas based on the terms, monomial, binomial and trinomial. Okay, so here what they have told, to divide a given polynomial by a linear polynomial. Now linear means what? The degree is 1. Okay, by synthetic division method. So synthetic division method you should know, and that you need to compare the remainder. Whatever the remainder you get, that you have to compare with the remainder theorem. That means here two method you are going to apply for one question itself. That is synthetic division method and remainder theorem method. Okay, and using this two method, whatever the remainder is there, it should be it will be same. So here you need to show that. Okay, so a question strip with the dividend polynomial and the divisor polynomial is given. You can see here the question strip which is in the blue. Okay, and here procedure is given, steps are given. So what is the question strip? Let us see the question strip. Divide x raised to 4 minus 3x square minus 8 by x plus 4. Now this is x plus 4, it is a linear polynomial. Okay, it is a linear polynomial. That means what? Degree is 1. By synthetic division, okay, that means you have to carry out the synthetic division and compare the remainder. So whatever the remainder we get by using the synthetic division, that remainder you will check with the remainder theorem also. Okay, so see the working part. Remainder theorem, remainder by remainder theorem. Okay, dividend polynomial, that is p of x, x raised to 4 minus 3x square minus 8. This is the dividend. Then divisor is what? X plus 4. Okay, so whenever you are using the remainder theorem, you first and foremost check out the divisor. Okay, if the divisor it is positive, then you have to take the value as negative. If the divisor is negative, you have to take the value as positive. Okay, so here the divisor is what? X plus 4. Okay, that means it is positive. So the value of x you will take it as what? Minus 4. X is equal to minus 4, because when plus 4, when it goes to the other side of the equal to sign, it will become minus. Okay, similarly, if it is x minus 4, so this minus 4, when it goes to the other side, it will become x is equal to 4. So this is very, very important steps, that whenever you are carrying out the remainder theorem or the synthetic division, the first and foremost step is that you just check out the divisor, but whether it is positive or negative. Okay, then let x is equal to minus 4. Okay, let x is equal to minus 4 as x plus 4. If I'll equal to 0, the value of x will be minus 4. So this x is equal to minus 4, you need to substitute in this dividend. Okay, you need to substitute in this dividend. When you substitute in this dividend, whatever the answer you get, that is the remainder. Okay, whatever the answer you get, that is the remainder. So here when I substitute x raised to 4 minus 3x square minus 8, that means instead of x you will substitute minus 4. Okay, like suppose if you are absent for one day, if you are a monitor, suppose if you are a monitor and if you are absent for one day, then on that day teacher replace another students in place of you. Okay, so that place is not empty, it will be occupied by some other person. Okay, so here also this x raised to 4, it need to be replaced or it need to be substituted by minus 4. Okay, so minus 4 raised to 4 minus 3 into minus 4 raised to 2 minus 8. Okay, accordingly, you will get the answer as remainder equals to 200. Now this remainder, whatever you have got it over here, it is by remainder theorem. Okay, and they have told to check, means to find the remainder by remainder theorem, also to find the remainder by the synthetic division method, and then compare the two remainders, whatever the remainders you are getting. So first of all, we have got the remainder by the remainder theorem, that is 200. So mark as 1. Now remainder by synthetic division. Now synthetic division, as you know that whatever the dividend is there, okay, dividend, it should be arranged in an ascending order. Okay, the polynomial, it should be arranged in an ascending order. If it is not, then you need to arrange. Okay, so here x raised to 4 minus 3x square minus 8, it is already arranged. This is the first step. Second step, standard form of the dividend, standard form or the coefficient form. Okay, here they have used the word standard form, but if you will see in your textbook, it is a coefficient form. Now students, what do you mean by the word coefficient? Coefficient means what? Numbers. Coefficient means what? Numbers. So whatever the polynomial it is given to you, you need to write the coefficient. You need to write the coefficient, and that coefficient you need to write along with their sign. This is very, very important. You need to write along with their sign. Okay, so let us check. First of all, as I told you that you need to arrange in an ascending order. Okay, so x raised to 4 minus 3x square minus 8, it is already arranged. Then coefficient form or the standard form of the dividend. So x raised to 4, that means here no coefficient is there, means what? It is 1. Okay, it is what? 1. Minus. Now here you can see the degree 4. After degree 4, it should be 3. Then 2. Then 1. And at the last, constant term. At the last what? Constant term. So here after 4, the term with the degree 3 is missing. Is what? Missing. So whatever the absent or the missing term is there, there you will put it as 0. Okay, there you will put the coefficient as 0. Then after 3, 2. So the coefficient of the degree 2 is already present, that is what? Minus 3. You will not write only 3. You need to write what? Minus 3, because the sign of the 3 is what? Minus. I told you that you need to write the coefficient along with their sign. So it is what? Minus 3. After 3, after 2, the degree should be 1. So here the term with the degree 1 is not there. So here you will write what? 0. Okay, here you will write what? 0. And at last, after 1, after the degree 1, at the last, there should be a constant. So here constant is already present. That is what? Minus 8. Okay, that is what? Minus 8. So here all the coefficients I have written 1, 0, minus 3, 0, minus 8. Okay. Now divisor of the polynomial is what? X plus 4, same. Okay. So let's check with the synthetic method. Now this is the way you carry out the division by synthetic division. Okay, this is the way, this is the format, or this is the way. Normal division you carry out like this, but here you should do the synthetic division in this form. Now here you need to write the divisor, and divisor, as I told you, that if it is plus, then you need to write in the minus form. Okay, because that is the value of the x. And on the top, all the coefficient, this coefficient form, which we have written 1, 0, minus 3, 0, minus 8. Okay. Now, how we are going to start with it? This first number, carry forward down as it is. Okay. Then 1 into minus 4, it will be minus 4. So here below 0, it is minus 4. Okay. Now 0 minus 4, it will be what? Minus 4. Okay. Minus, then again minus 4 into minus 4, it will be plus 16. Okay. So minus 3 plus 16. Sorry. What you will get? Plus 13. Okay. Here you can see. Then 13 multiplied by minus 4. Okay. It is what? Minus 52. So 0 minus 52. You will get minus 52. Minus 52 multiplied by minus 4. 208. Okay. So minus 8 plus 208 will give you what? 200. So that is the remainder. So whatever answer comes in your last box or the last number, that is always your remainder. Okay. Whatever the answer you get at the last or in the last number. Okay. So that last number is nothing but it is a remainder, and whenever you get that remainder, students, you need to make a box. That means it is identify that whatever is written in the box is a remainder. Okay. So this is a divisor. This is the dividend. This is the remainder. Okay. And here you can see this part. This part, it is nothing but it is a quotient. It is a quotient. Okay. Now this we will see how to write in the polynomial form further. Okay. So right now you can see that by the remainder theorem, you got the remainder as 0, and using the synthetic division, the remainder is also 0. So this marked as 2. So from 1 and 2, what we conclude or what we have observed that whatever method we are applying, whatever the method we are applying, whether it is a remainder theorem, whether it is a synthetic division, okay, you will get the same answer, same remainder. Okay, you will get the same remainder. So remainder from remainder theorem and synthetic divisions are what? Same. That is the conclusion part of the practical. Okay. What is the conclusion? That remainder from the remainder theorem and using the synthetic division, both are what? Same. I hope that this practical is clear. That is a practical number 4. Okay. Next, on page number 12, you can see some solved example, students, over here. Okay. Now, in this solved example, you can see the second question, that is the synthetic division. See here, as I told you, that remainder, whatever the last number you are getting, that is a remainder and you need to make a box. Okay, so it is highlighted, it is distinguished, it is understood that that particular number is a remainder, whatever it is. It may be a 0, it may be any number, it may be a positive, it may be a negative, whatever the number is, you need to make a box. Okay, now I will explain how to write the quotient, because this is your divisor. Okay, this is, as I told you, the coefficient form of the dividend. This is the remainder and quotient. Now quotient is what? 4 minus 13, and 10 means what? No sign is means what? Plus 10. Okay. Now see, students, what you have to do here, how many terms are there? 1, 2, 3. Okay. 3 terms are there. So if 3 terms are there, then every time you need to minus 1. If 4 terms are there, minus 1. 5 terms are there, minus 1. Okay, so every time the number of terms are there, whatever the your numbers you will get, terms, okay, in mathematical language, it is a term. Okay, so whatever the terms are there, that particular number of term minus 1. So here 4 minus 13 and plus 10. So 3 terms are there, so minus 1. It will be 2. It will be what? 2. Okay, so whenever you write the coefficient, whenever you write the quotient in the polynomial form, okay, so this is very, very important, that 2 will be the highest degree. So it will be what? 4x square. Since your polynomial in terms of x, you need to use x only. You cannot use any other variable except x. Okay. So 4x square minus 13x plus 10. Okay, 4x square minus 13x plus 10. So this is your quotient. This is your what? Quotient. And here it is in the coefficient form. And just now we have seen how to write it in the polynomial form. Okay, so whatever the number of terms are there, subtract from 1. If 3 are there, then 2. 4 are there, then 3. And whatever answer you get, that will be the highest degree. That will be the highest degree, and use the variable which is used in the question. Don't use, if it is given as x, don't use y or any other variable. Okay, so this is how you write the quotient in the polynomial form. Okay, now in the solved example, we'll see 1 or 2 activity question, then we'll stop. Now in the question number 3, now this third question, it is an activity based question which is continued on, fourth one is the activity based question. First 3 are the solved examples. Okay, so fourth one, that is use factor theorem to determine whether x plus 1 is a factor of 2x cube plus 7x square plus 6x plus 1. Complete the steps by filling the boxes. Now in this chapter, students, you will get 3 methods, okay, to carry out the division. One is the factor theorem, remainder theorem, and synthetic division. And all these 3 methods, okay, if you will use any one of it, you will get the same answer, same remainder. Okay, now your factor theorem, to determine whether x plus 1. So same x plus 1, that means x will be equal to minus 1. Okay, so wherever x is there, substitute minus 1. So p of x, we are finding the value, or we are determining whether x plus 1 is a factor of this particular polynomial or not. If you will get the answer as 0, if you get the answer as 0, then x plus 1 is a factor. Is a factor. If in case you get minus 1 or 5, means any number except 0, that means if you will not get the answer as 0, then this is not a factor. So to get a factor, or to determine, to check whether the particular polynomial is a factor of the given polynomial, then the value should be 0. If the value is 0, then it is a factor. If it is not 0, if you get any other number except 0, then it is not a factor. Okay, so p of x is equal to 2x cube plus 7x square plus 6x plus 1. This is the polynomial given to you, that is the dividend. Divisor is what? Divisor equals to minus 1. Okay.
Hello, ma'am. Sorry to interrupt.
Yeah.
होता लेगा?
हो एक हे कंप्लीट करते.
Okay, okay, ma'am.
Last 1 minute. Okay. So p of minus 1 equals to 2 into bracket is given, box given, that is minus 1 plus 7 into 1, that is square, plus 6 into 1 plus 1. Okay. So minus 2, because minus 1, the cube of minus 1, it will be minus 1. Whereas the square of minus 1, it will be 1. Okay. Cube root of any negative number is a negative, or cube of any number is a negative, whereas square of any number is always positive. These two different things are there. When you take the cube of any negative number, it will be always negative. Whereas if you take the square of any number, whether it is a positive number or a negative number, you will always get a positive number itself. Okay. So minus 1 cube, it will be minus 1 only. So 2 into minus 1, minus 2. Then minus 1 square, it will be 1. So 7 into 1, it will be 7. Then 6 into minus 1. Here you can write down the minus 1. Okay, I have missed out. Here also minus 1. Okay. Plus 1. So minus 2 plus 7 minus 6 plus 1. Again, follow the Bodmas rule. And answer is what? 0. So here you got the answer as 0. That means x plus 1 is a factor of the given polynomial. Okay. So this is how you carry out the factor theorem. I hope that whatever we have done up to this is clear and you have noted down or taken the screenshot